Hello and welcome. My name is Lee McLaughlin, and today I'm going to take you through some intermediate Python tutorials where we will take a look at a few examples and work it out on screen together. As someone who is new to Python, this is my take at solving some of these problems with a background in Java. By the end of this video, I hope that you can learn how to approach some of these problems from a programmer's perspective. Seeing how another person can interpret the problem can help to give you a sense of direction. Alright, so now that we have that out of the way, let's look at our first example. So I'm just going to open this folder with VS Code. Alright. So our problem is going to be as follows. The first one is we're given an input of n. We're going to find the sum of all digits. If the value of n has more than one digit, repeat the previous step. So for a digit of just purely 1, that's basically going to be our total, so 2. For, let's say, 2 digits, we're adding both together, so the 1 and the 2 in this case. So you can see 3, 1, 2, 3, 4, 1 plus 2 plus 3 plus 4 is equal to 10. However, this leaves us with 2 digits, and as you can see in the second line here on line 4, if it has more than 1, repeat the step. So what this tells us already is that we're going to be working with most likely some form of a recursive algorithm. So anyways, with the 10, 1 plus 0, as you can see, leaves us with 1, 5, 6, 9, 9. We get 29, 2 digits, 2 plus 9, 11, and then 1 plus 1, 2. So we had to do that step 3 times. So that's going to be what we're aiming for. So I just started up a quick little thing to get us started here. So just to show you that this works on VS Code, we'll enter in an integer. So if I were to take 12, right now it's not set up, but this right here, this calc function is going to be where we're writing this all out. So the way that I like to kind of take a problem that is recursive is we need to figure out what the break segment of the recursive algorithm is going to be. And the best way in our case, just by looking over here, is when a number reaches exactly 1 digit, that's going to be our break. So we're going to code our loop to be like so. This is where we're going to break. So the way that we can do this, so a user will give us n. N can be like 1, 12, 14, just some number. Is we probably want to read it like a string. So the way I'm going to approach this is we're going to get the length of, how do I spell that? There we go. Of n. So what this does is n is being passed to us as an integer. We're taking the string and converting the integer to a string, and then we are getting the length with the length function. So now we can throw this into an if. So if length is equal to 1, so in the case here, if length is equal to 1, we're going to return n. And this will be the final result. And then we can throw in an else statement here. And this will basically specify if our length is greater than 1. So just an example. So right here, if we have something greater, so this will be like a 12, these big numbers. This is where we would, I guess, really get into the formula of this. So the way that I'm thinking about doing this is by creating a list. And I'm going to store each digit as a part into the list. So let's call this nums list. For this, we are going to specify for int x So what this will do is we're going to loop through everything that is in string, which is in the converted string of our number. So basically taking like 1, 2, 3, and we're storing each one in a list. And just to prove this, what I'm gonna do is I'm gonna print out our list num. So what will happen right now, that's fine. We're gonna run this again. So I'm gonna throw in 12, and as you can see, we get 1 and 2. So that's good, it works. Let's try a bigger number just to prove. As you can see, each one is its own separate instance, and that's exactly what we're looking for. So perfect. Now what we're going to do is we need to find a way where we add each of the numbers. So we've already separated the list. So we're going to, I guess, have a for loop running here. Sure, we don't want this in the else state. There we go. So in the for, we're going to say for x in list num. We're going to need to add this together and keep track of it. So I'm going to create a variable sum, which will just have 0 for now. So in sum, what we're going to do is we're going to add in each index from list num to it. So what this is going to do here is, so like if our list looks like 1, 2, 3, we're going to go through each instance for each loop. So 1 plus 2 plus 3, and it's going to keep gradually storing that sum here. Alright, so that's all well and dandy. Next thing that we're going to need to do, because this is going to be a recursive call, is we are going to call the function again. So this function is calc. We're going to pass it in the sum. And what this will do is it's going to loop all the way back up to the top, and with our new calculated sum, it's going to see if it still has, 1 digit or more. If it has more digits, we do another recursive call all the way until the end. So let's give it a try, see what happens. So I hit play here. Oh. Okay, please enter an integer to find the value of n. Let's start with 2. 2 should return 2. So that's perfect, it returns 2. Alright, here we go again. Let's go with 12, this should return 3. 3, perfect. Let's try one of these examples. 1, 2, 3, 4. That gives us 1. Gives us 1, perfect. And we're going to try this last number. So it gives us 2 there. And it gives us 2. Perfect. So that is basically a recursive function in Python. Okay guys, so now that the first example out of the way, I got another one set up for us. So this problem is going to be a little bit more math based, but it's not going to be too bad as I'm going to break it down into smaller steps for us today. So with a passed in number, we are going to determine if it is a narcissistic number in base 10. So to break it down, we're going to start with this value being 1,634. The first step here is to break it down into the number of digits. So this is 4 digits, as we can see here in step 1. In step 2, now we're going to take each digit and we're going to put it to the power of however long, or of however many digits long a number, the original number is. So 1 to the power of 4 plus 6 to the power of 4, and so on. And if the number when added together is equal to the exact same number, then we know that a number is narcissistic. So as you can see here, I just took the liberty of adding it all and showing you, but when everything is added together, we get 1,634 on the left side, and because it equals the right side, 1,634 is a narcissistic number. Now, let's get to coding this. So this is just a base template to start us off here, but basically the first step that we're going to do is we need to figure out the length of whatever value is being passed in. So kind of similar to the first example, we'll have another length variable. So length is equal to, so first thing that we have to do is get the string value of value and then call the length function on that. From there, we are going to put it through a loop because we have to add every single number together. So we'll get a for loop going here. So for x in the string, so string passed of value. So this will loop through every single number. I'll even give you a quick little example of that working here. Also, just as a heads up, if I run this, let's just disable some of these tests here real quick. Okay, so if I just run this on its own, what you'll see is just the test values being printed. I'm gonna undo that one so that we can see all of the numbers. So when we do this, we should only see 4. So 4, perfect. I'm gonna do the same now with value 2, which is 9,473. We should get 9473. 9473. So as we know, this is basically working perfectly. Let's get rid of these. Okay, those are uncommented now. So now that we have established, I guess, our loop, we need to add it together. So I'm actually just going to get a variable. Let's call this variable sum. We'll set this to a base value of 0. That way it can be declared as an integer. And then we are going to add to it the value of x to the power of length. So length, as we know, is however many digits long this is, and then x will be basically our variable here, so it would look like this. So we'd have x to the power of length, and this is all done here in our for loop for us. So x to the power of length, and then right here we are going to say if value is equal to sum, because by the end of this whole addition and multiplication and all of that, the values should be exactly the same, and if they are, then we know that we have a narcissistic value. So that looks, oh, I almost made a mistake there, but so for x, because we broke it down into a string, x is going to be a string. So we just need to typecast this here to being an int. So now that we run this, we should see that everything works perfect. So 1,634 from our example gives us 1,634, so we know that's true. The value of 4 should be narcissistic because on its own, 4 to the power of 1 is equal to just 4. So to the power of 1. So that's true. And then these other ones I've already tested. You can try it yourself as well, see. But yeah, that is example 2 in a nutshell, and I hope that this could help you. Yeah.